Hey guys, this is me Ajit and this is the third video of my machine learning course. And in this video, we're going to talk about indexing, slicing, and the most important one, conditional selection. So let me open my Jupyter notebook. And I've already created a notebook for this indexing and slicing video. So before learning about indexing and slicing, first of all we have to develop an idea that what does this indexing and slicing means. So indexing simply means accessing the value at a desired index, and slicing means grabbing a subsection of an array. Like we can develop an understanding of this slicing by taking the example of a cake. So when we take a slice of a cake, at that time we are taking just a part of the cake. In the same way, when we are talking or when we are dealing with arrays, then there might be cases when we don't need the whole array. We just need a subsection of array, and in that case we use slicing. So first I'll import NumPy, and now I'll create an array. And here we get our array. And what if we want to grab the element 8? So simply we have to pass the index of the element which we want to grab. Here the index is 8 and the element by itself is 8. That is why we get 8 as an output. What if we pass the index as 7? If we pass the index as 7, we'll get 7 as the output. Now I'm creating another array, arr equals to np dot a range. It should be 11 to 22. Now what if we want to grab the element 14? And for grabbing the element 14, we simply have to pass the index of the element 14. So what is the index of element 14? Now, as we have already learned in C, that indexing in array starts from 0. So this is the 0th index, this is the first index, this is the second index, and this is the third index. So for grabbing the element 14, we simply have to pass the index as 3. And here we can see that we got our output as element 14. Now I think that you all have understand that what does this indexing means and how we can do indexing on array. Now we are going to talk about slicing. So I'm creating the array again. Equals to np.a range 0 to 11. Now what if we want to grab the subsection of this array, an array from 0 to 5? For that we use slicing. So how we can do slicing is, first we have to give the starting index, which is the 0th index, and then we have to pass the stopping index. And the thing which we have to keep in mind, that the starting index is inclusive and the stopping index is exclusive. Like we will see this when we'll get an output. Like we want to grab 0 to 5. So simply we have to pass the index as 6. And here we can see that we get the subsection of this array which starts from 0 and ends at 5. So as I told you that the stopping index is exclusive. So I want to grab the element from 0 to 5, and element 5 is at 5th index. That is why I have to use 6 as the stopping index. Now what if we want to grab element from 5 to 10? So what we will simply do, arr 5 colon 11. And why we passed 11 as stopping index? Because we know that the stopping index is exclusive. Now we can save some typing by just using this, and we get the same output here too. Like when we want to grab something from any index to the ending index, then mentioning the stopping index is not mandatory. And in the same case, if we want to grab an array from starting to a particular index, in that case we don't need to mention the starting index. Like I'm showing you this with an example. Here I want to grab the subsection of this array from 0 to 6. So what I can simply do is I'll simply use colon and have to grab till 6. So I pass this stopping parameter as 7. And here we can see that we got our array which starts from 0 and ends at 6. Now what if we want to grab the entire array? In that case, so what we can simply do is just put the colon here, and here we can see that we got the same array here. Well, NumPy array is different from normal Python list because of their ability to broadcast. Now let me go ahead and show you an example of this. Like I'm taking an array arr and grab 0 to 5, and then I can set it equal to 200, and what that is going to do is broadcast that value to those first 5 digits to all be 200, and that's what broadcast means. Now I'm going to show you that how simple Python is. Like I'm showing you the code that how you can reverse an array by just with a snap of a finger. Like first I'll create the array np.a range 0 to 11, and here we can see that this is our array. Now what if we want to reverse this array? So for reversing this array, what I have to simply do is pass the step size as -1. Here we can see that we get the reversed array, and this is also known as reverse indexing. But this is just a trick. You cannot use this in your interviews. Now I want to show you some important notes on slices of an array. Like I'm going to get the slice of array arr 5 elements. Now I'm going to check the slice of my array, slice arr, and here we can see that we get the slice of our array. Now what if I use that broadcast feature on this slice array equals to 99? Now when I'll check my slice array, I'll find that all the elements of my slice array has become 99. Now here we have to pay careful attention. If I call back the original array, what we'll find that it actually changes the values not just on slice but also on the original array, which means the data is not actually just copied, it is a view of the original array. Now you might think, why NumPy does that? Well, NumPy does that to avoid memory issues on very large arrays. Meaning NumPy is not gonna automatically set copies of arrays. Now the question is how we can create a copy and not just a reference of the original array. What we can do is specifically specify copy. I can do something like this: arr copy is equals to arr dot copy, and use the copy method of the array to specifically indicate that I want a copy. And if I take a look at my array, it is 999999999 and so on. And if I take a look at my array copy, it is also the same thing. Now what I'm trying to show you is that when I made a change on our array copy, ARR copy, I'm going to broadcast this equals to 100. Now when I check the ARR copy, I find that all the elements of this array has become 100. And when I'll check the original array, I'll find that the elements of my original array has not changed. So in the case, if we want to create a copy of an array, so we have to specifically use the copy method. Now I'm going to show you that how we can perform slicing and indexing on 2D arrays. So there are two methods for indexing and slicing on 2D arrays. The first one is double bracket method and the second one is comma within single bracket method. Well, first we are going to see the double bracket method. Now I'm going to create a 2D array. ARR is equals to np.array 3 4 5 6. Here we can see that we got a 2D array, and first I'm showing you that how you can perform indexing on this 2D array. So for indexing, here I'm using the double bracket method. So what if we want to grab the element 5? So here we can see that element 5 is in the second row and in the second column. So what we have to do is pass the row 1 and the column as 1. Here we can see that we have grabbed the element 5. Now why I have passed the row as 1 and the column as 1? Because as I've already told you that indexing an array starts from 0. That is why the row number also starts from 0 and the column number also starts from 0. That is why 0 indicates the first row and 1 indicates the second row. In the same way, 0 indicates the first column and 1 indicates the second column. Now what if we want to grab the element 6? So what I can do is ARR 1, 2, and here we can see that we got the element 6. Now about slicing using the double bracket method. Now what if we want to grab the element 5 and 6? Now listen carefully what I'm saying. The first bracket deals with the rows and the second bracket deals with the columns. So here we want to grab the element 5 and 6. So we know that the first bracket deals with the rows. So we have to see that which row contains the element 5 and 6. Here we can see that the second row contains the element 5 and 6. So that is why we have passed the row as 1. Now we have selected a row, and we know that the second bracket deals with the columns. Now the element 5 and 6 both are in the same row, so we can treat this like a 1D array, and we can perform the slicing operations in the same way that we have used in the 1D array, and that is why I have used 1 and colon here. I'm showing you another example where I want to grab the element 1 and 2, and for that first we have to see that which row contains the element 1 and 2. So here we can see that the first row contains the element 1 and 2. That is why I'm passing the row index as 0, and then we can treat this as a 1D array. So which column contains the element 1 and 2? Column 1 and 2 contains the element 1 and 2. That is why column 2. And here we can see that we got our output as element 1 and 2. Now we are going to talk about conditional selection. As the name itself reveals that conditional selection means that we are going to impose any kind of condition on our array, and only those elements will be outputted to satisfy that given condition. So now I'm showing you this with an example. First I'm going to create an array arr is equals to np dot a range 1 to 11. And here we can see that our array, 111 not 11. Now I'm going to impose a condition, like only those elements can be selected who are greater than 5. So arr greater than 5. And here we can see that we got a Boolean array. Now we are going to store this here equals to arr greater than 5. Now we can see our bool array. Now what if we want these elements instead of these Boolean values? For that, we can simply do this. And here we can see that we got only those elements which are greater than 5. We can also write this like this, arr greater than 5. We got the same result as we have got here. Now, why I've told you that conditional selection is very important, because the data which you get from the internet or from any other sources contains garbage values, impurities. That's why our first task is to clean the data, pre-process the data, and find the pattern in the data. And only after that we can find that which algorithm will work best for that data set. And at times you will find some cases when you require only those elements from the data sets which satisfy a following condition. In that case, conditional selection will be very handy. And these kind of scenarios will be seen very oftenly in machine learning. And that is why developing a better understanding of conditional selection becomes very important. Like I'm showing this with an example, like I'm creating an array np.random.rand int, and the starting price 1000 and the maximum price goes up to 7000. I'm producing 70 elements. Now I'm going to check this array, and here we can see that we got an array with 70 elements. Now treat this as the Amazon t-shirt price data set. Now what we want those t-shirts whose price is less than 3000. So what we will do, arr less than 3000, and here we can see that we got all the elements whose value is less than 3000. Now when we relate this with the Amazon data set, then we will find that we got all those t-shirts whose price is less than 3000. Now what you have to do is to practice as much as you can, like create 5x5 metrics, 10x10 metrics, and indexing and slicing on them, and perform conditional selection on those metrics, because the more you practice, the better you will develop your concepts. And that's all for this video. Thank you.